Hi, I'm Dr. Robin, aka Double O Pi. In this video, we're going to discuss how to use stoichiometry on lab data from a gravimetric analysis. First of all, let's define the term gravimetric analysis. The word gravimetric refers to the measurement of mass. So in a gravimetric analysis, you use a mass measurement to determine how much of your analyte is present. The actual process of gravimetric analysis involves creating a precipitate that you can weigh. So how do you do that? Well, you start with a solution. This might be a solution with an unknown amount of your analyte, or a solution you make by adding a known mass of solid to water. Then you add a reagent that forms a precipitate. For example, here's a precipitate that was formed after adding silver nitrate to an unknown containing chloride. In this case, the precipitate formed is silver chloride. After filtering the precipitate out of solution and drying it, you can get a mass of this precipitate. Well, okay, now you have a mass for your precipitate, but what does that mean for the amount of analyte in your unknown? Here's where stoichiometry comes in. Before you get started, here's some reference data you need to find. A balanced chemical equation showing the precipitation reaction, the formula weight of the precipitate, and possibly also of your analyte, and of course, you'll need the measurements you made in lab. You're always going to start with the mass of precipitate that you measured. Use the formula weight of your precipitate to convert that value into moles of your precipitate. Next, you'll use the mole ratio from your balanced equation to convert from moles of precipitate to moles of analyte. Let's look at an example in which you're trying to analyze how much chloride is in an unknown. In other words, chloride is your analyte. After adding silver nitrate, you produce a precipitate, and after filtering and drying, you end up with 0.8734 grams of silver chloride. Again, to do these calculations, you'll need a balanced equation for the reaction and the formula weight of our precipitate, silver chloride. Start with the mass of your precipitate, 0.8734 grams of silver chloride. Next, use the formula weight of silver chloride to convert to moles of silver chloride. Note that if you can't remember whether to multiply or divide, you can rewrite the formula weight this way. 1 mole of silver chloride equals 143.32 grams of silver chloride. Then, figure out which one you want on top or bottom of your conversion factor based on the units. In this case, you want the grams of silver chloride to cancel out, so we put grams on the bottom and moles on the top. If you were to stop here, you'd see that our precipitate consists of 0.006094 moles of silver chloride precipitate, but you're going to continue on. Next, you'll use the mole ratio from the balanced equation. Here you can see that for every mole of chloride you start with, you make 1 mole of silver chloride. So now you'll put in your conversion factor based on the mole ratio and double check your units. You can see that in order to end up with 0.006094 moles of silver chloride precipitate, you must have started with the same number of moles of chloride. By now you're thinking, but Dr. Robin, I'm not supposed to calculate moles of my analyte. Of course not. But how you proceed from here depends on whether your original sample was a liquid or a solid. So let's start by looking at how you would calculate things for a solid sample. If you started with a solid sample, the next step is to calculate the mass of analyte that was present in the original sample. To do that, use the formula weight of your analyte to convert the number of moles to the mass in grams. Now, it's possible that this was all you were asked to find, in which case you're done. But more likely, you were asked to find the mass percent of the analyte. In that case, you'll take the mass of analyte that you just calculated, divide it by the total mass of the sample, and convert to a percent. So now let's go back to the chloride example. Let's say you were given a solid sample and you weighed out 1.0453 grams of sample and dissolved it in water. Only then did you add the silver nitrate that reacts to form 0.8734 grams of precipitate. Remember that there were 0.006094 moles of chloride in your original sample, so now you'll use the formula weight of chloride to convert that to grams of chloride. Again, you can look at the relationship that 1 mole of chloride equals 35.453 grams of chloride and decide which of these two goes on top or bottom based on what you need to make the units work. Here that's going to be grams on top and moles on bottom. If you do the math, you can see that you have 0.2161 grams of chloride. And if that's all you were asked to calculate, you can stop there. But odds are good that you've been asked to calculate the mass percent of chloride in the sample. So you're now going to take that mass and divide by the mass of sample you started with. That was 1.0453 grams, and multiply by 100%. Your sample was originally 20.67% chloride. In summary, to find how much analyte was in your solid unknown, start with the mass of the precipitate, then use the formula weight to find moles of precipitate. Use the mole ratio to convert to moles of analyte, then convert that to the mass of analyte using the formula weight. Finally, if you need a mass percent, divide by the mass of sample you weighed out at the beginning and multiply by 100%. So what if you started with a liquid sample instead? In this case, you're probably looking for the concentration of the analyte in molarity. Remember, molarity is moles per liter, and you've already calculated the number of moles. So now all you have to do is divide by the volume of sample you started with in liters. That will give you the molarity. Back to the chloride example again. This time, let's say you were given a liquid sample and you used your 50 ml volumetric pipette to transfer an aliquot into your beaker. After that, you added the silver nitrate that reacted to form 0.8734 grams of precipitate. You started with 50 mils of solution, which equals 0.050 liters. So the molarity of chloride in our original sample would be the number of moles we calculated earlier, divided by our volume in liters, or 0.1219 molar. Again, for a liquid sample, the first three steps are exactly the same as they were for the solid sample. But after you calculate the moles of analyte, you divide by the volume of your sample in liters. Before we wrap up here, if you found this video helpful, please take a moment to click all of the things to engage with the YouTube algorithm. So just a reminder that stoichiometry is one of those things that you kind of have to work with on a case-by-case basis. I showed you an example using a silver chloride precipitate, but there are literally dozens of different gravimetric analyses that you could perform. The two processes I've shown you in this video walk you through the most common ways of doing stoichiometry for a gravimetric analysis. But you could be asked to report your results in other ways too. For example, you might have a liquid sample for which you're asked to calculate concentration in grams per liter. Based on what I've just shown you, can you figure out how to do that? As always, thanks for watching. I'm looking forward to seeing you again on the channel soon. Dr. Robin, signing out.